Hello friends, there was a recent tweet that caught my attention from Chi Girl stating the US ISM manufacturing headline series is closely correlated with yields, and an interesting chart from Bloomberg that shows the 10-year yield in dark black and in light gray the US ISM manufacturing numbers. Now, why is one dark black? It's because it's a daily number, the yields are daily, and the light gray is because it's a monthly number. So whenever you have a daily number and a monthly number, you must be, and they tell you it's correlated, you must be going, ooh, this is good to know, right? It's something I can use if I need a PMI estimate and I don't quite have it yet. I could always get a decent estimate from the 10-year yield, and that's exactly what popped in my head. And especially building this chart and getting the data is actually fairly trivial, and that's what we're going to do in this hands-on episode. So the Chi Girl, one of the feeds, the economic feeds I follow, posts tons of economic data. I'm actually not the only one that follows her. Over 50,000 people do it too. I actually follow a whole bunch of people like this, because they kind of are like our eyes, many different eyes looking at different things in the market, and they can report back. And once in a while, we don't listen to everything, but once in a while there's a few things that catches our attention and says, oh, this is something I like to have in my fundamental economic indicator toolbox. And this is definitely one I want to not only make a video of, but also use it. So, first of all, welcome to the Viral ML Show. My name is Manuel Amonategi. You can get more information at the viralml.com site. Please sign up for my newsletter. It's right in the middle of viralml.com here. Sign up. You'll get early access to my material and even deals on classes and books. This video will be classified under channels and finance, where you'll find all of my other videos and walkthroughs and code on finance. And definitely subscribe to the YouTube channel and give it some thumbs up, right? That means that people are appreciating the material and kind of encourages me to do some more. So as usual, we're going to jump to the Jupyter Notebook. And let's get some data. So we're going to get two data sets from the same site. We're both going to get them from Quandl. I've used Quandl many times. I'm sure you're familiar by now, but if you aren't, Quandl is a free site. You can get a free account, right? They won't ask for a credit card number, and a percentage of the information on Quandl is free. A lot of it is not free. They have very interesting things like parking lot occupancy and these kind of things, but that you have to pay for, unfortunately. But this stuff is free. So the first thing, you'll see the two links here. We're going to start with a PMI. And here it is, a PMI. Just click the link, hit max to make sure you have as much data as possible, and hit download to CSV. And that will download the CSV to your local machine. And do the same thing for the Treasury yield curve rates. Hit max to make sure you have as much as possible. Hit download CSV, and that will download it to your local machine. So, quick word on the ISM. The ISM is an interesting indicator because it's not a quantitative indicator in of itself. It's actually two organizations, including I think I got a link. Here is one that's involved with it, the ISM Institute for Supply Management, and another company, which the name eludes me right now, but they send out surveys to industry leaders around the world. They make PMIs for the US, for other countries. They make like a global PMI, and then they get all this information back every month, and they compile a list. And people basically say it says a 50. Imagine the 50 line here. If a series of questions like employment, supplies, sales, all these things, if they rate it above a 50, if it's above a 50, that means people are seeing a positive outlook. If it's below a 50 line, it's a negative outlook. So I really like that kind of approach because it's not only from business leaders, but it's also not quantitative. Well, of course, the yield, right, is it's decided between different banks, the feds, all sorts of different things. So very interesting to know that these are correlated in that way. So obviously they kind of there is some inbreeding somewhere somehow, but we don't care about that right now. We just want to be able to plot it and see if we can see similarities enough to be able to say, hey, whenever I need a PMI number, I can get it by looking at the 10-year yield. So once you have those things all downloaded to your local machine, I actually now start using a path that says where I put this data. Let's start by loading the ISM. So, you make sure you get the correct name from what it was downloaded to your local machine. And here it is. I'm using pandas read_CSV. I'm casting the date to a date time. It's actually an object. I'm also, printing the min-max date because I want to see how much data we have. Sorting it. That's very important. Always sort your data, especially if you're going to work with moving averages, which we are. You always want to make sure the moving averages start with the oldest data and works its way to the newest data. And I'm also going to do a percentage change. Percentage change is nice because the price, your price action basically is really one price and where it went next, and the fact that it accumulates the previous price in it. It's basically historical. The price change is just really where was it at this point and what did it do? Did it go up 1? Then it'll be 1. It doesn't care if it was originally at 200 and goes to 201. No, it just went 1, right? So it's and then it calculates that change in percentages. So you can compare different financial products because now they're all on the same scale, the percentage scale. They're not on a dollar scale anymore. And we're going to do a tail, make sure everything looks good. And here it is. The data is loaded, including the percentage change, the one we just added. To do the percentage change is super simple. You pass it the series you want, and you go .pct_change, and it's built into pandas, and it'll do the percentage change automatically, right? So you can see we're going 54.2 to 55.3, and the percentage change is a positive number, right? Yeah, I was looking at it the right way. Yeah. So let's do the same thing with the treasuries. We're gonna, it's exactly the same thing because it comes from the same data source. So I'm not gonna talk about it too much. Here we get a lot of data back. We get all sorts of rates and all sorts of yields, and I really recommend that you experiment with them all. We're gonna only look at a 10-year here, and I created a 10-year percentage change as well. So obviously, right, let's go back to the chart from Chi Girl. Here it is, right, which is actually a Bloomberg chart. Let's see if we can reproduce this chart. So let's picture that in our minds and say, okay, let's make that. So I'm going to simply cut it off. It looks like it's plotted from 2011, starting 2011. So I'm gonna do the same thing. I'm gonna start 2011. I'm gonna make copies of our data frames just because I like to be able to, play around with different date ranges and not have to reload and clean up the data every time. So this allows us to kind of work off of a copy every time, and I can just change the date, and we won't have to reload anything in memory. And now I'm going to basically use a matplotlib. I'm going to create a figure size of 16 by 8. It's perfect for Jupyter notebooks. I am then going to plot the date and the PMI. I'm going to color in blue and label it appropriately. I'm going to title it PMI and 10-year yield, and I'm going to put the legend in the lower right. I'm going to have a grid. The grid is going to help us see things. I'm going to open a second axis, meaning that we're going to have two y-axes now, even though it's the ax.twinx. It's going to allow you to have, to share the x-axis. So that's why they're saying, twinx, because they're both going to be using the same date axis. But the y-axis, right, one will be PMI, which oscillates around 50, and the 10-year is a yield, right? So we'll have to work from there. So so to open a new y-axis, you just simply call ax.twinx, and you can open 20 different axes, and it'll allow you to plot all sorts of information as long as you have one, the x-axis that is common between both. And we're going to plot the 10-year in red. So when I plot this, look at this, right? Actually, you know what? Let's change this to black. It'll be a little easier to compare it to the Bloomberg chart. And let me go back and forth between the Bloomberg chart. I mean, it looks pretty similar, right? It goes up. It goes up here. There's a little bit of air here. Oops. There's a little bit of air here, right? So keep in mind we're over. This is kind of matplotlib that's doing its best job at kind of overlaying both charts. So Bloomberg is doing its own thing on its own side. So they're not going to be perfect, but you can see we're looking at more or less the same information, and it does look correlated, doesn't it? Look at that. It's there was a little bit of difference here. It looks like the PMI went up, had maybe a more positive outlook, while the yield went down. And same thing here. This bottomed before the 10-year, and and otherwise it's going down right around the same time. So pretty amazing, right? So if you're looking for a synthetic, a proxy of the PMI, the manufacturing index, I mean the 10-year looks pretty good. So let's join them. I'm not going to bother running a Pearson's correlation on this because it's similar in nature, but the fact that one is a daily and the other one is a monthly is going to be very hard to get a clean correlation. Overall, you can see the shapes are very similar, right? And actually, what we can do is because I'm doing this nifty little copying the data frames, we can then change this very easily. Let's go with 1995. And see a lot more, and see if that through time that's the same thing. And it does look like it's very similar here. So definitely here from 1994 to 2002, very similar. it looks like some moves are exaggerated right here. The PMI was starting to get negative here. Look at that. Well, the 10-year was just climbing slowly, right? Then right around was 2008, right? The Great Recession. They both tanked. So obviously, these are overlaid differently, right? They're different scales. But they definitely seem to have, some overall correlation. We can join both data. Let's do a little bit more experimentation. We can join both of these by calling PD merge, panda merge on the rates, because it's a daily one, and the PMI, which is a monthly one, and we're going to do it on the left, right? A left join. So PD merge is like doing a SQL join. We're going to do it on the left side. This is daily, so we're going to have more data, and we're going to basically match the PMIs to the daily, and all the gaps, because one is monthly, one is daily. We're just going to do a forward fill, and that allows us to fill without cheating. That means, if there is, we're basically going to go back in time, take the last value and forward fill it. So we're never cheating, we're never peeking into the future. That's very important, right, when we're doing modeling. And now it's going to allow us to have these two data frames sharing a date. And that's going to help us to be able to do the percentage change with a little bit of more ease, but not necessarily. We could have done it without it. But now I want to use the percentage change. So the percentage change, like I said, right, it ignores the historical price and just looks at the change between one point to the next and ignores everything that happened before. And we're going to overlay the PMI percentage change with a 10-year percentage change. And look at that, right? It's very hard to read, and that's partly because there's just so much more 10-year data than there are of PMI data. So one thing we can do is we can add some rolling average. That's kind of really the reason I'm doing this. I want to show you guys how to use the rolling average. So you simply take your series, kind of we did with the percentage change. You say your series, and you go dot rolling, and here we add the window. The window means that how much you're gonna smooth it. So let's say you want to smooth it by a 5 period. Your window would be 5 periods, meaning it's going to take 5 periods, take the mean of that, and that will be the 6th value, right? And move it one. The 7th value will be the next 5 right before, and that will be the 7th, and so on and so forth. Min period it will basically backfill the information, so there's no gaps in the data. And the mean, that's what we're doing, right? We're taking a rolling mean, and I'm gonna color it in blue. And the 10-year, I'm gonna do a stronger one. I'm gonna do a 25 period. That's gonna allow us to really smooth it, because one is daily, one is monthly. We should really, try to do like a 30-day or kind of like a month, right? So this one. So I'm really not applying any smoothing to the PMI, and I'm doing, a 25 period to the 10-year, right? So hopefully they're more or less kind of like become monthly data, right? This is more or less rough. I'm also going to multiply the resulting 10-year, just because otherwise it would be too small. So this is going to allow us to see it. So the 10-year will be in green and the PMI will be in blue. And when I run this, and here, so it's still not excellent, but we can still see a little bit more. It does look like here it's going up. There's more green, a lot more green here, and it goes down. So let's zoom in, right? Again, because we can work off temporary copies. I'm going to zoom in 2005. We're just going to look at a few years, and I'm going to run the exact same chart. So here we have it. It's a lot easier to see now, right? So remember, the percentage change oscillates around the 0 line, right? Because it can go up or down, and it's going to be a positive and negative number. So both are going to rotate around that 0 line. And the fact, these are just artifacts of starting the moving average. We're going to kind of just look at this part. It's more interesting. But here we can see, right, the PMI in blue is above 0, meaning it's positive. So is the yield. Then it goes down. So is the yield. There's a little disconnect here, and let's look at some other easy ones. Right, the PMI goes up. This whole period is up, and look at that. The 10-year yield is also positive. Here as well, right? A little bit less. And now this is interesting around the end, right? So the PMI was more positive while the yield went below 0, and now most of everything is happening under 0. So we're kind of in a negative PMI / lower yield area, right? So there is definitely a correlation, and it may be of use to you if you need a synthetic proxy to the PMI and you don't want to wait 30 days. So before I finish, I like to kind of plug my books. This one, the most appropriate one for this show, is the little book of fundamental indicators, where we do exactly this kind of stuff. We look at the CPI, we look at the VIX, the fear index, the S&P 500, unemployment, and it's all about finding the data, whether Quandl, Yahoo, other sites, the Feds, and learning to plot them and to analyze them, to look at them and learn from them. So there's also each chapter has a companion website to help you along. You can also find my books on Amazon. Other books as well. And here it is, right? Here, little book, Fundamental Indicator. Simply put my first and last name in Amazon. And I also have a Udemy class that I just finished recently called Fundamental Market Analysis with Python, where I created a series of videos very similar to these I'm doing here, with also hands-on Python coding, and kind of go through all sorts of details. So if you're interested in kind of understanding what's going on in the fundamental world, whether it's for your general understanding of the markets, your own investing or your own trading, I highly recommend taking the fundamentals seriously. Thanks for watching.